Welcome students. So today's objective is to perform the tensile test on a rectangular beam of dimension given is 100 mm into 100 mm into 1000 mm. The dimension is same as we have completed our earlier objective, but here the change is that we have to perform a tensile load, and in the previous lab we have performed a compressive load. Everything else is same, that we have to calculate the deformation while changing the tensile load starting from 100 newton to 1000 newton. So what we have to do, first you have to calculate first you have to choose the static structure, double click on it and wait for the opening. And here is the tree, and for the tree all engineering data is already included. And if you want any specific material that is not included in engineering data, then you have to double click it, and then you have to add your engineering data here. So we have not going to deal with this. So first go to geometry, right click on it and click open new design modular geometry, then wait for the opening. After opening, as you know, we have the dimension in mm, so click on the unit and click on the millimeter. So as I have already discussed you, that you have the two methods to create a rectangular beam. First is by creating a sketch, then second method is direct. So I'm going to go with direct. Click on it, create, go to primitives, then go to box, and here box, the by default dimensions are 30 into 30 into 30, then change it to 100 into 100 into 1000, then click on the generate. So this is your geometry, and what you have to go to, just go to file and then close. The software will automatically saves your thing, so there is no need to save it. Now go to model and right click on the model and click on the edit button and wait for the opening of particular program. Now this is how it's open, then click and wait for its opening. Yeah, now it's open. First click on the mesh and create update and wait for the mesh. Now if you are not satisfied with this mesh, then you can go to advanced size function, go to proximity, go to directly go to fine, so that you will have a better mesh. Poor mesh will not give you the proper results. Okay, then go to this and move it here in any direction you want. There is no issue. Then you have to perform a tensile test. Go to static structure, right click on it, insert, and first you have to give a fixed support. Okay, fixed support. Now to go to this, and I'm going to give the fixed support to this side. Then this is your fixed support, and again go to this, go to insert and apply the force. The force is, I'm going to apply force on this surface. So click on it, go apply this, apply. Then I should take the value of 100 Newton as per the problem statement. And here you can see that the direction is tensile direction, so there is no need to change the direction. Okay. Then the ultimate, what is the requirement, that you have to calculate the total deformation. So go to solution, right click on it, insert, click on the deformation and the total deformation. Now as you can see that there is a requirement to solve this, so click on the solve button and then wait for the results. Yeah, now after the solution look like this, and here you can check that the maximum deformation is 4.98 into 10 to the power minus 5, and also you can also go to animation and check this. Now this is your deformation. If you want to change this, then you can also increase the number of frames for the smoothness, and also you can increase the time also. Yes, this is your time, so that you can easily check what is the moment. Here the blue means you have the zero deformation, and the red means you have the maximum deformation. And this side is the fixed support, and here from here we are applying the tensile load. That is why the length is increasing. Okay, but as an engineer the values are very important. So the value is 4.98 into 10 to the power minus 5. Now stop this and change the force value to 500 Newton, and then again solve it and wait for the results. Yes, and the result what we get is the deformation increases to 2.49 into 10 to the power minus 4. You can check the easily the deformation values here. So this is the for the checking purpose. This is your method. Now if you want to change further, then you can also change it to 1000 Newton. Then calculate. Yeah, and then the total deformation is 4.9 10 to the power minus 5. Yeah, I think I have missed 1 0 here, so this should be 1000 and solve it. Yeah, so the total deformation 4.9 10 to the power minus 5. This is your deformation. You can also change as per our objective. You have to calculate the total deformation. If you want to change something else, then you can change it. If let us suppose you want to the directional, then you can also calculate the directional deformation. Here are also outcome. You can also calculate the stress. You can also calculate the strain. You can also calculate the fatigue. It depends upon what you require, that we will discuss later on. But for the result purpose, what you have to do? You have to calculate. You have to draw a table that what is the deformation with respect to load. Okay, students. So this is what you have to do.